Thanks everyone for joining the talk, CloudTrail Logging Internals. A bit about myself. My name is Eliav Livneh. I'm a security researcher in the past 3 years at Hunters. And in my spare time, I have an amateur cover channel, and I like mining different rocks from various places around the world. But let's get to it. What we're going to talk about today is mainly how to investigate a CloudTrail and AWS security incident. We'll talk about which questions you should ask, how to ask those questions, and some CloudTrail internals that help answering those questions. And in the end, we'll also touch on a few interesting examples of how CloudTrail can be very complex, but if you know it well, how it can help you in your work. So let's start with an incident. And here I took a GuardDuty incident, a great place to start an example. Obviously, I changed all the IDs and API keys, etc. So what do we have here? We have an assumed role, admin, anonymously invoking discovery API calls. Okay, that doesn't give us much information. Now, the basic triage questions I would want to ask really straight off the bat, just to understand kind of what we have here are, first of all, who did this call? Who did this actions? What did they actually do? And where did they do it from? So let's see what the alert can give us in regards to those questions. So who did it? We see an assumed role, this role name admin, role session name IT admin, and some access key. That doesn't really answer our question much. What did they do? The alert says list users IAM call. Okay, still I don't really get a good understanding what happened. And from where? From this IP. We're going to delve into the first two questions as they are more CloudTrail specific. All right, so first of all, a disclaimer, there are plenty of ways of doing and achieving the results that we're trying to achieve here much easier, that'll give good results, but we're really going for the most accurate way we can that doesn't depend on any external services and that just rely on CloudTrail logs. And as a start, we must have all our CloudTrail logs accessible and queryable, but I won't go into that for now. Okay, so who did it? We know that this assumed role, admin, IT admin, was used, but we don't know who was actually using this identity. And finding this out is not really trivial to do. So we need to touch a bit on identity chains to be able to answer this better. What are identity chains? There are many different API calls in Amazon that actually pivot between identities. Some of them also pivot between different accounts, and some of them also change the actual ARN belonging to the identity. What they all do is they all generate a new set of temporary credentials. So for an example, a simple one, say I have a permanent IAM user with permanent credentials, and I call get session token, one of these calls. This generates a new set of temporary credentials belonging to the same ARN with the same permissions. Another example would be assume role call with the same IAM user, and I would assume role cross account to a different account, and I would get an assumed role in a different account with a new set of temporary credentials. However, it's called change for a reason because all these API calls can actually be changed. So let's look at a more complex example. Like before, we have an IAM user in account A, which calls get session token, which creates a new temporary identity, new temporary credentials, again, belonging to the same ARN, same account, assume role within the same account to basically an assumed role. So now the ARN changes to jump role Eliav L in the same account. And from here, I would call, for example, an assume role to a different account to get admin IT admin in account B. Now, this is common scenario that there are complex chains of these identity pivoting actions. And in fact, what we saw in the alert, GuardDuty gave us the last identity, the admin IT admin in the second account. So if we follow the chain backwards, we can actually answer accurately, at least in terms of the user originally doing this action, who did it. So we need to know all these events, and we need to know how to follow them back in the chain by jumping between these different CloudTrail events. And by following the chain backwards, we know who did it. Now there's a larger list of these events. Kinnaird is giving a talk, I think later today, has a repository with all these events. Okay, so we have all the ARNs related to activity. why not just search for all the events with those ARNs, right? So it's not so simple because ARNs aren't really unique. Different people and different services can use the same ARN or have the same assumed role ARN at the same time. So if we search for that ARN, we might get results from different sessions happening at the same time. And again, we're going for an accurate result here. So if ARNs aren't unique, what are unique? API access keys. So if it's just regular API calls done with an SDK, it's simple. We just need to follow the identity chain. Each one of these temporary credentials or permanent credentials from the example earlier also has an access key together with it. And all we have to do is take those access keys. Great. However, web sessions are a bit different because, right, web console only requires a username and password. All API calls require an API access key and a secret key. So how does the web console work? And from as far as I know, all this is undocumented. So what I've discovered so far, that when a user logs in with a username and password, behind the scenes, temporary sets of credentials are dynamically generated and make API calls on your behalf and then display that in the console. What I've discovered so far is that actually a different access key is generated for each region you work in. Sometimes I've even seen multiple access keys at the same region generated. So in this case, how can we know what are the access keys that are part of this session, because it doesn't use the same chain as before? So the way you can know this, how you can find this, is that we find the original console login event responsible in showing the actual login at first, and then say we have events coming afterwards because, for example, I browse the EC2 service page. So if I see those later events that have an identical ARN to the ARN in the console login event, and whose session context creation date for the access key is identical to the event time of the console login, that way I know that these are related and a part of the same web session. And then I need to take the access keys in all those further events, and I know that they are dynamically generated and part of all this session. By the way, it doesn't only have to be console login. If you assume a role or switch roles through the portal, or just have a timeout after about an hour, the portal behind the scenes will call switch role and renew role, which also both of these are undocumented. And the same thing would have to happen here for the events that follow after these events. Okay, wonderful. So now we have all the relevant access keys for the session, whether if it's a web session or a non-web session. What do we have to do now? We just search for all the CloudTrail events with those access keys and we'll get the answer. This is technically true. However, it's very hard to consume because every single API call is logged in CloudTrail separately. So even basic web sessions last only a few minutes can generate thousands of events, which makes it hard to consume. And logging isn't entirely comprehensive because the accuracy of logging varies across different services. I'm not sure, but I'm pretty sure that different services need to implement their own CloudTrail logging, which makes them not log things in the same way. Some of them also populate some other fields differently. Let's take a look at a few of these examples. Let's say, first of all, the resource field. So it points to the resource that the action was done on, which is very critical for context because a snapshot being taken from a prod DC server, then a snapshot being taken from a dev test machine is wildly different. So it's important to have this in context. Unfortunately, this field is only being populated by about 10% of the services, with some significant services not populating this field at all. So this is a bit of a bummer, and we see it's optional true. However, when it is populated, we do use it. We'll see it soon. A different field, read only. This field helps understanding if the API call changed the resource or not, and this helps in zooming in on more interesting actions because usually if a call changed the resource, it's a more interesting and high-profile action for an attacker to do than read-only events. Before I prepared for this talk, once this field was only 20% populated. However, I was glad to see that during the end of last year, CloudTrail now populates 100% of this field for all events, which is wonderful. However, again, this isn't a wonderful indicator for this isn't a 100% indicator for what is interesting or not, because there are read-only events that are very interesting. So we also maintain a list of those special kind of like events. Another interesting field, request parameters to get the target resource. So sometimes, most times, the resource field is unpopulated. Then we can use the request parameters because usually we have there some sort of parameter indicating what the target resource is. However, these parameter names aren't standardized at all, even within the same service. Also, when an API call fails with access denied, the request parameters for some reason is always empty. But as we've seen in the talk before by the great talk by Noam earlier, the error message is not. So we can extract the resource just like they do in what he talked about. We can extract the resource from here, so that's great. And also, in resource searching API calls, like searching for a specific instance, then there's a generic parameter usually called filter set, where we can consistently find the resource being searched for. Okay, so what do? We basically group by API call, for example, describe instances and all other API calls. And for each of these API calls in the thousands of logs of a session, we do a number of things. First of all, we count the number of overall calls for that API call, specifically how many of them succeeded and how many of them failed. And then a bit more trickier things based on the quirks I showed earlier. We extract the sample of the resources JSON, hoping that it's populated. If not, then we extract a resource from IAM access denied messages if there happen to be such in the event, because if it's a service that doesn't populate the resource, maybe it does populate that field, which is great. And when not, we can also we can use the request parameters JSON as well to see, maybe there we can see a reference to the target resource that gets that helps us get the context of what happened. And we also specifically extract the filter set parameter that I mentioned earlier for resource searching events. And we also finally extract the sample error message to see if there were errors in general. So what does this give us? From thousands of rows with lots of events that take hours to look at manually, I know because I've done it many, many, many times to get an understanding of what actually happened, we get a much more concise result showing that, and it's more easily consumable, and you can get a better, quick understanding of what actually happened in the session just by glancing at it for like 1 or 2 minutes. So looking at this, we can briefly see in the read-only statistics that the user looked at the group S3 read-only and also looked at the user test user and also at this prod code reader account user. And more interestingly, in the non-read-only events or more sensitive events, you can see we only have here about 15 overall summarized rows. We can see here basically what he did. He created a role called Eliav Livneh test role, created a user, attached this role to an instance, and so forth, and some other interesting things we see. Otherwise, he called switch role in the portal 10 times and failed all of those times because of invalid parameters, and also tried assuming a role, but also got an IAM access failed. He tried assuming this specific role. All of these are extracted from different fields. So very quickly, I can get an understanding of what happened, and this saves a lot of time to a person investigating AWS incidents. To briefly touch on, in the time I have left, on two interesting findings we had that also exemplify how complex CloudTrail is, but that if you really get to know the internals of it, how it can show you interesting things. The first thing is that actual defensive agent technique we found based on how CloudTrail logs VPC endpoints and calls to VPC endpoints. The basic way to explain it is that when an attacker is using compromised credentials belonging to a victim, he can spoof the source IP address that appears in the victim's CloudTrail logs for the actions he does. Let's take a look how that would happen. So let's say a victim has an AWS account, and in that account he has a user, and that user has credentials. The attacker can also create his own account. All is required is a credit card. And in that account, he creates a VPC, giving the VPC an internal CIDR block in the IP address range that he wants to spoof. Now, this uses a powerful feature that AWS allows to do. You can create VPCs with internal IP addresses to be in any subnet you want, almost besides maybe 2 subnets, but you don't only have to use private addresses like 10.0.0 or 172.16, etc. You can use any subnet you wish. In that VPC, the attacker would then create an EC2 instance and give it the exact IP he would like to spoof in the logs, and create a VPC endpoint in that VPC that allows making API calls directly within the VPC without making calls without going to the internet. Then the attacker just would have to use the credentials he stole. As we said, the technique assumed the credentials were already compromised by the attacker, uses those credentials through the VPC endpoint to make AWS calls. And what would be logged in the victim's CloudTrail logs for those calls is the source IP address that he picked, basically obfuscating the source IP address to be whatever he picked. And the second thing, I don't have much time to go over, any more time to go over this, but for anyone interested, we published a blog post and a podcast about this, so feel free to check it out later for more details. Obviously, I didn't touch all the details here. And last fun quirk. So as we said earlier, API keys are unique, right? They identify uniquely temporary or permanent credentials. However, during research, we discovered 2 different assume role calls in the same account in a span of 25 minutes in between that produced the same exact access key. And in fact, the second set of credentials were generated before the first ones even expired. So they existed at the same time, and they actually even had different ARNs belonging to them. So we communicated with AWS, and we discovered that indeed this is expected behavior because of the sheer amount of assume role calls that there are. And they also added to the documentation a note about it, them being unique only in the combination with the secret access key and session token. However, this is a fun fact, but it's not really a security risk because besides happening rarely, it's only recycled within the same account, and it still separates 2 different groups of permissions. So you can't manipulate this into, an attacker can use this for kind of like cross permissions between them. So it's just more interesting than crucial to know. In general, what can be done, I think AWS is wonderful in their logging, and CloudTrail is really amazing. As someone who works all day on CloudTrail, it really is good. However, optional fields can be populated better, I believe, and the documentation can be more accurate in these edge cases that I've shown before. And also AWS Detective, AWS's own service, can also improve on some of these things that aren't fully 100% accurate, and to make it easier for the lives of security teams. So thank you very much for listening, and feedback is much appreciated. And questions, I would gladly ask and answer any questions if anyone has.